Hello? 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 Hello?
Okay, so
Hello?
mic is on and we'll start it.
Hello?
Okay, so
Hello?
mic is on
Hello,
and we'll start
everyone.
it. Okay,
Hello?
mic is on
Hello,
and we'll start
everyone.
it.
Hello,
Okay,
everyone. My name is Samyak Nagran.
mic
So,
is on
hello,
and we'll start
everyone.
it.
Introducing
Okay,
myself. My name is Samyak Nagran.
so
And
mic is
hello,
on and we'll
everyone.
start it.
Introducing
So
myself. My name is
so
Samyak
okay,
Nagran.
so
And
mic is
hello,
on and we'll start.
and since introducing
Okay,
myself,
so
my name is Samyak Nagran.
mic
And
is
hello,
on and we'll
and
start.
since introducing myself,
So
my name is Samyak Nagran.
mic
And
is
hello,
on and we'll start.
and since introducing myself, my name is Samyak
Okay,
Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself. My name is Samyak Nagran. So I thought that this is a good introducing myself.
okay. Default is headset. Okay. Lock it. Hello.
Okay.
Default is headset. Okay. Lock it. Hello.
Okay.
Default is headset. Okay. Lock it. Okay, so micचा audio 0 ठेवायचा and the desktop audio should also be set to 0 and I need to add a audio input capture. ओके म्हणजे जितकं पण वेळ मी बोलत होतो आता हे आता पूर्ण वेळ म्यूट वर होतं. Sure. तर परत एकदा इंट्रोड्यूस करतो. Hello everyone, my name is Samyak Nagran and I am currently preparing. मला स्वतःचा आवाज परत का येतो इकडनं? अरे हा, अरे ही स्ट्रीम इथे म्यूट करू दे. Okay, just a sec. Hmm. So I'll just start by introducing myself again. So hello everyone, my name is Samyak Nagran. Samyak Nagran. आणि and I have been procrastinating a lot since the last month, and I have not been solving any kind of coding questions or any kind of questions on various platforms like GFG and LeetCode. So I'll just try. So I thought of a way so that I can hold myself accountable for solving and get consistent while preparing for my campus placements or off campus placements. So the best way, so the problem was that I was spending too much time on my phone and just scrolling through Instagram Reels, Facebook Reels, or YouTube Shorts, and just wasting my time on the social media platforms. So I thought of a way to repurpose my phone so that I am not able to scroll on on the social media platforms like Instagram, because I mainly spend my time on Instagram and then YouTube Shorts. And if I'm bored with both of these platforms, then I just scroll on Facebook and just watch memes. Okay, so enough about the problem. So the resource that I will be following, uh, or the roadmap that I will be using, is made by neetcode.io, which is who also has an extremely good YouTube channel where he has solutions to each and every question that is there in his roadmap. So I chose this roadmap uh, because he because he gives in-depth explanation and why some solutions are better than others, and he takes you to the approach step by step, from the brute force approach to the most optimized solution. And also there are other I mainly code in C++, so he also provides multiple programming languages where we can see the solutions to the code. So that's why I chose this specific one. So I think we should start with stack. And the two thing and I so in this session or in this live stream, I am aiming to solve these two questions, that is valid parentheses and min stack. I have previously solved both of these questions sometime in June or July 2023, but I have not revised any kind of stack or any coding questions that make use of stack. So, okay, so let's just start. And yes, I make use of light mode because I like light mode. Okay, so let's see what the question says. Valid parenthesis given a string as containing characters brackets. Determine if the input string is valid. And input string is valid if open brackets must be closed by the same type of brackets and open brackets must be closed in the correct order. Every closed bracket must have a corresponding. Okay. Okay, so first we have opening bracket, round opening bracket, followed by round closing bracket. So this is a valid string or a valid parenthesis. Then here we have a opening round, opening or closing round. Okay, then we have a opening. Okay, okay. Okay, input. Okay, so here we have a opening round bracket, but a closing square bracket. Basically, there is no corresponding closing round bracket, or and there is no corresponding opening square bracket. So that's why this parenthesis is invalid. So okay, so the approach I can think of it is like is this. So if closing bracket, push in stack. If it is a closing bracket and a stack top is not opening bracket, then the return false. I mean, this is what I can think of. See, if it is a closing bracket, then push it in stack. It is as easy as that. And if in the input string we encounter a closing bracket, then there are two options. I mean, there are two conditions that we need to check. First is if the string has a closing bracket and the stack top is a closing bracket, we will pop it until we encounter the same type of opening bracket. Okay, and okay, so I'll just check my solutions. See, I had solved this one with a few code. Okay, so first I have created a stack. So I have made use of the standard template library, and I will just iterate over the string. Yes, so extract the current character from the string. Then if the current character is any kind of opening bracket, just push it into the stack. And in the else case, there are two conditions possible. Stack is empty or not empty. Yes. So if we encounter a closing bracket and the stack is empty, meaning that there does not exist a corresponding opening bracket, and this indicates that the string is a invalid parenthesis. So if the stack is empty, that is right here, we will return false. Else, if stack is not empty, we will check if the stack top is the corresponding opening bracket like this. So if the current character is a closing round bracket, we will check if the stack top is a opening round bracket. And the same for the curly brackets and the square brackets. If this is the case, we will simply pop it. Else, we will return false. And after we have iterated over the entire string, we will just check for edge case. That is if the stack is not empty. If the stack is not empty after we have processed the entire string, then our given parenthesis is invalid. Else we will else so the else case is pretty clear. We have processed the entire string and the stack is also empty, meaning that the string or the input was a valid parenthesis, and in this case we will return true. Okay, so if I just code this solution, I know all that we have already seen its solutions, but I still just want to code one time so that I know what the actual C++ syntax is. So I'll just do that. So okay, stack char st. Then I will just iterate over the entire input string, int I equal to 0, I less than s dot size or length. I mean whatever is easy, because now size or length give the same stuff, or or they have the same functionality. Okay, so I will extract the current character. Char ch is the current character from a string. So yes. So the first condition is as follows: if ch is a opening bracket. If it is a opening bracket, we will simply push it. So it's a if condition. If ch is equals to, sorry, it's a character. What is this? Okay, sorry, my bad. I just pressed some other key. Okay, where is the standing line? I have no idea what do they even call it. Oh, it's here. Or it's a square bracket, hyphen, any kind. In such case, we'll just push it. st.push and push the current character. Excuse me. Now in else condition, as as I previously said, two conditions are possible: stack empty or not empty. Stack empty or not empty. Now we'll check for two conditions. Stack is empty. So if the current character is a closing bracket and the stack is empty, meaning that this is not a valid parenthesis, so we'll just check for this condition if stack dot empty. If stack is empty, then return false. No wait. Ah yes. If it is a invalid parenthesis, we have to return false. And now we have to check. We have to check is what stack is non-empty. Okay, stack is non-empty. Check for stack top. So if ch ch is equals to a opening bracket. Okay, what did I just do? F11. Hmm. And stack dot top is a responding. Wait, I'm so sorry. I just did it exactly opposite. If the current character is opening and the stack top is closing, then we have to pop. Okay, so I'll just copy this. So I'll just copy this right here, paste it, and paste it. Because we have to check the same conditions for three kinds of brackets. My bad. And now for the curly bracket. And if that is the case, we will simply pop it. st.pop. And we'll just continue. Okay, and where does the for loop end? For loop ends here. Now, string has been processed. String has been okay, so the string has been processed now, and we will check if stack is empty. Check if stack is empty or not. Basically, it is just a insurance, or we are just making sure that if our string or the our given input is a valid parenthesis or not. Check if stack is empty or not. So if stack is empty, if stack becomes empty, we will return true, meaning that our given input, oh my god, meaning that our given input is true, or else I'll return false. Okay, now let's just run it. Okay, so actually, what I did just now is a bad thing because when you go for coding, or what I mean is when you go for any kind of interviews, well, the interviewer will ask you to code the solution to the coding problem, not in an code editor, and they will ask you to write the code in a document or a text editor such as Google Docs, Words, or simply a notepad. So after you have written your code, just make sure that you are proof reading the code so that you can catch the basic syntax error and just check if your logic that you have thought has been successfully translated into code. So just make sure that yes, but now we know that our code works, but still I'll just make sure that that our code is following the syntax and we have taken care or we have thought of the edge cases. Okay, first declare the stack, then for loop for processing the string. Extract the current character, that is a bracket. If it is a closing bracket, push it into the stack, else meaning that the current character is a closing bracket. So just now check for two more conditions. Stack is empty, stack is non-empty. If the stack is empty, it is an invalid parenthesis. If the stack is not empty, then just check if the stack top consists of the corresponding if the stack top consists of the corresponding opening bracket, and if this is true, then just pop it off. And after the string has been processed, just check if stack is empty. If stack is empty, then it is a valid parenthesis. Else, it is not a invalid parenthesis. But now we know. Okay, so I'll just like to add one more test case here. So we'll go like round curly braces, round square curly square round. Okay, so now we know that this is a successful case or this is a valid parenthesis. And now I will add an invalid parenthesis. Just opening brackets and one closing bracket. So now let's just run this. So case 5 should be true and case 4 should be true and case 5 should be false. Okay, so case 4 gives us true, case 5 is false and false. Okay, so we'll just submit it. Okay, see. Now this gives a wrong answer. And why is it a wrong answer? Huh, why is it a wrong answer? What did you do wrong? Okay. Okay, so first it's a opening bracket. So first it's a opening bracket. So first opening bracket. So stack will just a second. I will make it up with the pen and paper. Okay, stack is now currently empty, so we get the first round opening bracket. I will push it into the stack. Okay. Then we have a then we have a okay, so what it okay, then we have a closing bracket. And when it is a closing bracket, we will check for two conditions. Is the stack empty? No. Stack is not empty. And if the current character is this and stack top is this, I think this should be else it. I'll just run it once. And I think now it should give the correct answer. Okay, test. Okay, so I'll just add this specific test case here and see how it performs. Case 5 should give us false. Okay, I have no clue where I'm going wrong. Okay, so I'll just check my previous submissions. What so difference with me? Okay, so I missed this condition. Yes, if the stack is empty, return false. But if we don't have the corresponding one, Okay. So sorry, this was a mistake on my part. See, first is this. So if the current character is a close bracket, check for two conditions. Stack is empty, stack is not empty. So if the stack is empty, return false. And the else case becomes like this. We will check this. So inside else, there are two more conditions to be checked. I have no idea how I miss this basic. And else I will have if again. I'm in this condition. Okay, I forgot if. And this will get evaluated. So if this is true, we'll pop it. Else, return false. Now I'll just run it, and the case 5 is where you case 5 is where yes, now it's solved. I'll just submit it. But how is that people are getting to such faster solutions? Code sample runtime 0. Okay. Okay, so they have okay, so they have optimized the final checking condition. So it's just basically return if the stack is empty or not. If the stack is empty. Okay, so the empty function itself returns a boolean value. If stack is empty, it returns true. If stack is not empty, it returns false. Okay, so now I'll just make a flashcard of this. I'll just go to remnote because I make use of this. And I think I have already solved this question. So there will be a flashcard that is available for it. So I'll just search valid parenthesis. Yes, there is a valid parenthesis. Yes, I'll just, yep, it's the same exact solution. Okay, I've copied the entirety. Then here is a neat code. I want to create a document. Valid parenthesis. And then I want to tag it stack. And I'll just link it here because it is extremely easier for me in the future to reference it. So what I'm saying, link to website, and I'll just paste the okay. Oh no, rookie mistake. So I'll search again valid parenthesis. Thank God it's here. Copy the entirety of the flashcard, then go to this folder, go to valid parenthesis, just paste it. Very good, it has been pasted. What is this? To do flashcards to enable flashcards. I have no idea what is this. So how will this flashcard look? Answer. Analyze. Okay. The space complexity will be big often because we are making use of a stack. Because we are making use of a stack. And the time complexity will also be, I think in the worst case, it will be big of n because we are evaluating the entirety of or we are processing it. So I think that is correct. And in neat code, how many? What? Okay, what does this mean? This one here. Oh, okay, so we just audit for now. Go here. Oh no, this is the stream. Then market is done. The next problem that I will attempt to do is the min stack problem. And I have already, I think, do it because we have to design a stack. And I think in this problem, we make use of the pair data structure. Basically, we store the minimum value and we store the current minimum value, right? So what will it be constructor and push into val, push pop, get min in top. Just a second, I'll just plug in my PC. I mean my monitor. I mean my laptop. What? Sorry for that. You as this is the entire as this is the first time I am doing a live stream. Okay, what does min stack? I may have already solved it. Very good. And I'm too lazy to think of a new solution from scratch. And I know that this defeats the entire purpose of this revision, but still, min stack. Okay. So the class will just have a vector of pairs. So basically a vector which will have pairs, and the pair will be as follows, like this: pair int comma int. So the first will be the current value, and the second integer will always represent the minimum value in the stack. So this is min value of the stack. So push. Okay. So when you push onto a stack, what will I check? If the current value, if the current value is smaller than the stack tops than the current minimum, then I will update the minimum value. See, if oh okay no. If the stack is empty, meaning that the current value will also be the minimum value and the first value. But if the stack is not empty, I will have to check if this current value is smaller than the current minimum value. See, yes, we will create a and p dot second. P dot second is just minimum of value and stack dot size minus one. Because here actually st is not a stack. We are making use of a vector, so we just need to check of this we just need to check the second of the second last one, because zero based indexing, and we'll just push it. Pop is simple, stack is not empty, push return it back, or just pop it and we'll return it. Get dot top hmm, and get min return. So this was pretty straight forward. We will make use of a pair. Okay, so that was a bad idea. So I'll just keep it here for future reference in case I do this. So first, okay, so this is the class main stack. So I will make use of a public, oh, and it has a public, wait, a public, private, and protected. These are called as access modifiers. And so this as a public access modifier, meaning that anyone can use this class and the function. So first I will declare my data structure that I will use to represent the main stack. So declare the data structure that is used to represent the stack, or the min stack in this case. It will be a vector. It, it will be a vector of type pair, and the pair itself will be of type int comma int. And I will call this vector as stack because that is the aim that we want to design. And the first function that we have to implement here is void push. So it will push the element in the stack. Right. So now just check if the stack is empty or not. If stack is empty, if it is empty, so I'll make a new pair, pair int comma int p, p dot first equal to p dot second equal to val, and I'll just push this pair into the stack. Stack dot push back because stack is not actually a stack, it is still a vector of pairs. Sorry, push back, right? And the else case will be stack is not empty. Stack is not empty. Check for check for check for the minimum value. So this first create a pair p. P dot first will be the current value, and then p dot second will just be the minimum of this value and the previous step term, which is value and stack second last term. So that will be stack dot size minus one because zero based indexing. It's second, right? Is this the correct syntax? Because I know the pair has two uh, pointers that we can use, the first and the second. So okay, so what does this do? Stack. Okay, I am accessing my vector. Then I want to access the current element. That is the last element minus one because zero based indexing, and it's second one. Yes. And I'll just push it into the stack, okay? Stack dot pushback. This pair. And as it is what I will not return anything. What does pop want to do? Removes the element. Okay, pop will simply remove the element. We don't have to return the element or get the pop element, popped element. So in the case of pop, we also have to think about a concept called as underflow, meaning that if the stack is already empty, we cannot pop a element, or basically we cannot pop something that already exists. So so I'll just do this. If if dot stack is not empty is equals to false. So if stack of empty returns false, I will simply pop back because this is a vector, so it has pop back and push back. Else case I'll just simply return, because if the stack is empty, then we cannot pop anything. Get top, it will get the top element of the stack. If here we want the top element from the stack, and we don't care about the minimum element, so we'll simply return. Okay, so I think I should also check if the stack is empty or not. Yes, I think I should. If stack dot empty constraints. Okay, so these will be always called on non-empty stacks, pop, top, and getman. So, but I'll still write this so that I can make sure that the stack is still not empty. If the stack empty returns false, then I will return that current element which I can access through the size operator or the size function minus one and its first, meaning the vector's topmost pair's first element that is used to indicate the topmost value. And if the stack is not empty, I'll just return minus one. -1 or int min, I guess would be a better one. Okay, no, the value. Okay, but as the constraints of the questions suggest, the pop, top, and get main will always be called on non empty stack. So this if condition and this written -1 conditions, these two are redundant conditions. And same for get min. I'll again check if the stack is empty or not. If stack is sorry, if the stack is not empty, I will return the minimum value, which uh, which is indicated by the topmost element per second element. Basically, we made use of a pair because it can store two values at a time. That is the current value of the stack, and it can also store the minimum element of the stack. So that's why you used it, or else we will just return -1. Yes, now time for proofreading. Vector parent in stack. This is the data structure that we are going to use to design the min stack. Void push stack. If stack is empty, we will just simply push it. Else, if stack is not empty, we will check for the minimum element. Meaning if the current element is minimum or not. Then pop is easy. Just pop it back. Same for top and same for min. I think this should run, but we also thought this was the previous element. Okay, let's see. Yes, st.empty. St will not work because the correct name or the name we have given to the vector is stack. Right? Okay, I forgot a semicolon. Even after proofreading, there are errors here. Very good. I hope there are no more errors or basic. Okay, accepted. So I'll just try to submit it once. And I think I have also done this previously. Yes, I have also done it previously. Max stack sliding window maximum. Are these two here? Max stack sliding. No, these are not here. So okay, min stack has been done. I'll make sure to add it here. And I'm sure that I have already done this. See, min stack is here. So just copy the entirety of it, go into this folder, min stack, paste it here, and I'll just take a new screenshot here because I'm not happy with the color scheme or I have not inputted the design here. Print screen, where's the print screen button? So I'll just take a screenshot of this and paste it here. Then minimize it. Wait, why won't it let me? Okay, then enter. Oh no, this is the back of the card. No, 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 no. Okay, so I'll add another photo here and then add the arrow because I still want to add this example and also the because they're important. Now I will add this. The back of the card will look like this. Now let's just check. Wait a second. What? Okay, do I copy this into the back of the card? I'll just check the preview. Show answer. We can easily, and then we also have the code. Is the code not showing? Hello? Wait, Control tab or Alt tab. Okay, so this does not work. Control tab, tab, control tab. No wait, shift tab. Hmm. Shift tab. So but basically we know what to do. So oh yes, we need to tag it stack, then link it so that I think tomorrow's live stream we'll just focus on doing the flashcards. So let's check it out. Min stack, valid parentheses. So we did these two today. And yes, I guess that's it for today. So so I just need to plan for tomorrow. Which questions do I do tomorrow? Generate parentheses and evaluate a reverse Polish notation. I have studied the reverse Polish notation in my second year of computer engineering in a subject called as fundamentals of data structures, but I have no idea whatsoever uh, what reverse Polish notation means because I have forgotten it everything. Because I have forgotten the concept entirely. Okay, I'll just check how did they write the code? Okay, so they made use of another map forward. Okay, to store it. Okay, to store it. Okay, iterate it. If input dot find C is not equal to if input what is open here? If open dot okay stack is open given stack of opens check for matching closes and validity. Okay, so the map has this both the pairs of open and closing. If we find the current parenthesis, I have no idea what does this mean. If find dot C is not equal to end, if input starts with closing bracket, if open is already empty. Okay, so in the stack open, we are just pushing the opening brackets. And if it is empty, put in false. And if open dot top, meaning stack top is not the corresponding, it is not the corresponding character. Got it, got it. Because we are just checking for the closing brackets, and the closing brackets are then mapped to the opening brackets. Okay, open dot empty. And if open dot top, meaning that the stack top does not have the corresponding type of the closing bracket, then return false. Else we will simply pop it because we have found the corresponding pair, right, of the opening. Basically, we have found the matching pairs of the opening and closing bracket. So just pop it, meaning that that pair of the parentheses has been successfully evaluated. Else, we'll simply push and we'll just return open dot empty. So if stack is empty, return true. If stack is not empty, return false. Understood. And what about min stack? Two stacks, one normal and one monotonic decrement. Okay, decreasing. Only push if lower than top. But push. Okay, so he has made use of two stacks. But where has he declared these two stacks? Okay, so these are in private. Stack and min stack. If min stack is empty, okay, or value is less than min stack dot first. So why has he used two stacks? I mean, he could have used just one stack. I don't see the value or why he has used two stacks. I mean, that's it. And I guess in the next live stream, we can do either I mean, we can start with flashcards and then we can also solve one or two of these questions. That is, evaluate the reverse Polish notation and generate parentheses. So I guess that's for today. Thank you for anyone that is watching here, and I will see you in the next stream. Thank you and good night. And it's now 21:34, so it's 9:30 here right now. And I think I started at 8:50 or 8:45. So a 45 minute stream. Wait, I'll just check here. No, it's a 51-minute stream. Are there any concurrent viewers? No. Are there any views? No. Because I have not promoted or added any kind of things to it. So yes, that's it. So I'll stop the stream now and have a good night.